Hi everyone, my name is Anvita Bansal and today we are going to discuss another problem, that is trapping rainwater problem from your SD sheet. So let's move to your sheet and see which problem we are solving today. This is trapping rainwater and you must have already gone through this problem. It has been asked in lots of interviews. Let's check the problem. So see, you are given an array of n non-negative integers representing the height of blocks. If width of each block is 1, compute how much water can be trapped between the blocks during the rainy season. So here you're given an array which looks something like this, which contains non-negative integers, and each integer represents the height of the block. Okay, imagine them as buildings. So this is building at 0th index in the array whose height is 3. The next building to it is of 0 height. The next to it is of 0 height. The width of each building can be considered as 1 unit each, that is fixed. Then the next building is of height 2, which we see here, and next to it is of height 0, and next to it is of height 4. So let's say these are the buildings, and you are this you are pouring some water, maybe rainfall is happening. Then how much amount of water will be stored between these buildings all together? That's a total amount of water that can be stored. That is what you need to return. So if you just visualize this picture, you will see that if, let's say, these are my three buildings and the buildings of height 0 are nothing, they are on the ground level, right? So from ground level till the bottom, from bottom till the topmost level, okay, how much water can be stored such that we don't consider the water that will be spilled, right? So if you see, this is the amount of water that can be stored. So if you were to calculate how much amount of water it is, you can simply calculate it in units in this way, that this is of how much unit. Let's imagine a building. So this will be a building of unit 1, 2, 3, 3, right? Then this will be of unit 2, right? 3 to 5. Then above this one unit, 6, 7, 8, 9, and 10. So I'll tell you how. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how you are calculating the amount of water that can be stored. So let's move to the whiteboard and understand how we can solve this problem. So I hope you were able to see my screen. Let's move to the whiteboard. So this is one test case I've already written, which you don't need to worry about. Let's have a look. How do we need to understand? Let me check it. Okay. And one sec. Look here. Okay. So if, let's say, these are the heights of my buildings I have given you, then how would you calculate the total amount of water that can be stored? Again, visualize it in this way, that this is some, let it be nothing but something like this. Okay, fine. So each building is considered of width 1 unit, right? First building is of 0 height. Then next building is of height 1. Next building is of height 0. Then next building is of height 2. So this is 0, 1, 2. Let's make it 2 like this. Okay. Then next to it is of height 1. Just next to it is of height 0. So we'll keep that empty. Then next to it is of height 1. Okay. Next to it is of height 3. So that will become this height, right? Next to that is of height 2. Then 1. 2 again. Then 1 again. Okay. So understand this problem. This is your 0th level. This is 1. This is 2. This is 2. This is 2. This is 1. This is 0. Okay, and the amount of water that can be stored in it would be. So 1 second. Hmm. So look here, how much water can be stored? I was looking to fill it with something, if I could. Okay. So can water be stored here? No, it cannot be. Why? Because there is no building to its left. Let's have a look here. Can we store some water in this position? Yes, we can. Why? Because there is some building to its left, there is some building to its right, which can hold the water. And the maximum amount of water that can be held within these buildings would be, maximum height would be the minimum of what is present in left and what is present at right, right? Understand it in this way. Let's say I had only two buildings, this and this. So maximum amount height of water would be the minimum of these two heights, right? Okay, fine. Then let's have a look here. Let's see at this space. So how much of water can be stored within this space? Let's see. So I can see that I'll find, let's say if this was my storage, so I'll check what is the maximum height I can get from the left, right? What would be the maximum length of tower on the left side? So I'll say that if I'm at this position and I try to find what is the maximum left index, maximum left height of the tower, I'll say I'm getting this one as the max, right? And so the amount of water would be everywhere. If you see, at any point, if I am able to store water, I am checking that what is the maximum of left height that I can find. Okay, this is some storage. So what I found was that maximum is this from left and maximum from right is this. What is the minimum of these two? This height. So maximum height that can be stored would be the height of left max in this case, right? And now the entire thing comes at every index. What I'm checking at every index. Okay, if I'm at this position, I am asking from left what is the maximum left if I find at this position. So I'll say that I'll get the tower 2 of maximum height. When I'm at this position, I'm checking from right. If you check from right, if you check what is the maximum height of the right tower. So it will say the maximum I can find is of height 3. This is height 3, right? So it now what is minimum of 2 and 3? It is 2. So this index will say that the maximum height that I can store would be the minimum of left max and right max, right? That is the height I can store. Same goes with the next index, same goes with this index. This index is also asking what is the left max. It will say the left max would be height 2. What is the right max? It will be height 3. So what is the maximum height that I can store? That would be minimum of the left max and right max, right? Now coming at the next index, if I'm at this index, let's say if I'm at this index, again what is it asking? It is asking that what is my left max? Left max in this case is what? So it says any tower that I can find from the left end is not greater than this height 3. This is height 3. So basically left max is also me and right max is also me because I don't find any tower on the right which is greater than me. So what is the minimum of these two? It will be 3 only. And what is the amount of water that I can store? That will be the height minimum of left and right minus my own height, which is 3 only. So basically zero amount of water is getting stored at this position. Okay, coming to the next position, let's say if I'm at this index, again it will ask what is the left max. It says left max is 3. What is the right max? From right, from it including this index and towards its right, what is the maximum height I can get for the right tower? It is of height 2. You see, this is also of 2, this is also of 2. This is the max height I can get. So at this position, what is the minimum of L max and R max, right? So that is 2 because R max is 2 and L max is 3. So minimum of these two is 2, which means that at this index, the maximum height that can be stored can be 2. But actual water storage will be found out the min of L max, R max minus its own height. Its own height, right? So what is its own height? Its own height, I was in this position, its own height is also 2. So what is the amount of water that I can store? Can I store any water here? No, because at left it can hold, but at right there is no tower to hold. So it will also store no water, 0. At this index, it says what is the left max? Left max says I am 3. Right max says I am 2. So what is the minimum of these two? That is 2. Now 2 minus its own height, that is 1. So basically one storage of water can be stored here, right? Okay. At this index, what is the left max? Left max is I am 3. Right max is what? See, including it, the right max that I'll get is 2 only. So what is the minimum of L and R? That will be 2 only. And what is its own height? That is 2. So 0 amount of water is getting stored here. Now when I'm at this position, left max is what? 3. But what is R max? R max is its own height. So minimum of L max and R max is its own height, that is 2. And 2 minus its own height is going to be 0. So that is going to store 0 amount of water. Because even if I store some water here, it will spill because there is no tower to hold. Understood this thing? So this is what I wanted to explain using this picture. So total amount of water, if you observe, that can be stored here is, this is of unit 1, this is of 1, this is of 1, this is of another one, this is of 1, and this is of 1, right? This is also of 1. 1. So 1, 2, 3, 4, 5, 6. Total is 6. That is the amount of water that it should return. Now, intuition is, what is the intuition? Basic intuition is that at any index that I am present, I am checking for what is the maximum height of tower from the left end of that value and what is the maximum height of tower at its right end. Okay. And using it, I can evaluate my answer. Now, first case that I'm going to discuss is brute force approach, the exact thing that I explained that we are going to. Right. So if I am able to maintain what? Maintain the left max for that index and the right max for that index. Can I simply return the answer? So let's have a look. So the first case would be when I'm maintaining the left max also and I'm maintaining the right max also. What would be the answer in that case and how will you evaluate that? So if I'm at 0th index, right? If I'm at 0th index and I want to calculate, let me write it this way. I am at 0, 1, 2, 3, 4, 5, 6, 8, 9, 10, 11. At 0th index, I'm calculating what is the maximum at the left, including that index, that is 0. I am at 1 index. What is the maximum I can find till this position? This value itself 1. How will you calculate it? You'll simply use a simple for loop starting from 0 to n at every index. If that index, if ARR of I is greater than, let's say, some L max you have stored, then this is, let's say, ARR of left max, and other we are going to store an array, use an array for storing the right max. And if that is the case, let's say it was 0 and our initially L max was also 0. If it is greater, then ARR of LM, let's say, is going to be filled with ARR of I, right? That is what we want to do here. So check here 1, and also update Lmax with ARR of I. That is all that we want to do. Now at this position at index 2, the height of tower is 0. What is the maximum Lmax at this case? At that position, Lmax would be 1. So 1 is not greater than 1 is greater than the current value is 0, right? Current value is 0. So L max for this index would be also be 1. right? So we will simply compare the L max if it is greater ARR of, or you can do this thing like this. If ARR of I is greater than L max, update the L max, and always, and if that is not the case, otherwise else, even if you don't use else, you always have to fill ARRI with L max. That's what you want to. Now, at this index, at index 3. So what is the ARR of I? ARR of I is 2 and L max is 1, right? So L max will become 2 now and ARR of I will be 2. That's what you want to do. At this position, your ARR of I is 1 and L max is 2. So for this also the L max would be 2, right? 2. Now at 7th index, it will become 3 because the value is 3 at this case. Then for rest of the other indices also, it will be 3 because there is no value which is greater than 3. So I hope this is clear. Now, similarly, I am going to create another array to store the right max. How will I store the right max? Look here. See, this is the brute force approach. Even if you find it easy or very intuitive, just try to understand what we are doing, because this is going to be very important for the optimized approach. Now for the right max, from right I am moving towards 0th index and checking that from right hand side what is the maximum height of right tower that I can find. So for this case, for the last index, what is maximum height of tower I can find? That is 1. So I fill it with 1. Okay, next one. At this position what is the height of the tower? Same thing I'm going to do for R max also. You can write it on your own, I think. Now at this position, what is that R max that I have 1, and the tower height itself is greater than the R max. R max will be updated to this value 2 and I will fill this array with 2. Now when I'm at this index, at this index, what is its own height? It's 1 and R max is 2. So I can simply write 2 here. Same for this case, it will be 2 because I haven't found any value which is greater than 2 as of now. For 7th index, it is going to be 3, and for previous other indexes also it is going to be 3. Then again for 5th index 3, for 4th index also 3, 3rd index also 3, 2nd index also 3, index 1 also 3, index 0 also 3. Let me check if all the indices that I have written are correct or not. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Same for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now at every index, for every index, I have L max. This is your L max. And the other one is your R max. This is your R max. For every index, if I have L max and R max, I can easily find what is the min of L max, what is min of L max and R max, and then subtract my own height, that is ARR of I, right? And add it to your answer, whatever answer you are keeping, in which you are storing the amount of water that you can store. Just simply add that value to it, and that would be your answer. So basically, if you check at 0th index, what is the min? That is 0. What is the ARR of 0? That is 0. So water answer will be 0 at this position. Okay, at index 1, minimum of 1 and 3. Minimum of 1 and 3 is 1. And what is its own height? It's also 1, so 0. Next index, minimum of 1 and 3 is 1. What is ARR of 2? 0. So 1 minus 0 is 1. So 1 will be stored here. Next, index 3, minimum 2. And at index, at index 3, minimum is 2. And what is its own height? That is also 2, so 0. At index 4, minimum 2. What is its own height? 1. So add 1 out of it. So like this, you will get answer 6. You can dry run this case. Fine. So in this case, in case 1, you took some space, right? You took two arrays to store the Lmax, and Rmax, right? And this is the reason your space becomes O of 2n, which can be written as O of n, right? And what is the time complexity? You once you are iterating over the array to calculate Lmax, once again you are running one loop on this array for calculating the Rmax, right? And once again you are running one loop, right, to check minimum of element to do this calculation, basically to do this calculation. So basically 3 times you are running the loop, not nested but at different times, one after the other. So O of 3n, which precisely can be written as O of n, but still here we are using some space. We can discuss one more approach, which is the optimal approach, in which we will not use any extra space, and we can solve this problem in exactly one pass. So what is that approach? That let's discuss that. Give me a second. Okay, coming back to this. So second approach, method that I want to discuss. Let me check you if you're able to see my screen and if things are clear till here. I hope it is. Okay. Yeah. Coming back to this problem, how can we solve it without using any extra space? So intuition is clear. Intuition is clear of finding Lmax and Rmax. Now I'm writing one pseudocode here, after which I'll tell you what we are doing. So this is an optimal approach, right? Because we won't be using any space. So obviously this is going to be a little bit tricky. Okay, so let's check what are we going to do. So if your, let's say there are 2 pointers, this is going to be a 2 pointers approach. Starting with left index 0, right index at last index of your array. If ARR of left, right, if let's say it is less than or equal to your ARR of R, then what? If it is smaller than the value present at your right index, then you are going to do some things. What are those things? Have a look. And same thing we are going to do for else case, which is else case would be when your ARR of right is less than or equal to ARR of left, right? So in that case, if again ARR of right is greater than or equal to R max, let's say R max also we are storing, then what are you going to do? Your ARR of R, if that becomes greater than R max, then obviously you will update your R max with ARR of R, And why we are doing so, just keep patience, I'll just come to it. Otherwise, you if your R max is greater than ARR, that means you can store some water, which will be answer R max minus ARR of R, right? And R max minus. And you are going to do all of these things while your left index is less than or equal to right index. Right. So this is part of it. Let's understand this one. So what am I saying here is, I'm saying that let's take two indices, left and right, and two max L max, which will initially be 0, R max also initially 0, and answer is the amount of water that is going to be stored. So initially that is also 0. So these are the variables that I have taken. Now, how do we understand it? Give me a second. I'm just looking. Okay. So coming back to a problem, what I want to explain here is that initially you have left 0, you have right equal to at index 11. Fine. You are checking if ARR of L is what? 0, and ARR of 11 is what? 1. Okay, 0 is less than 1. If that is the case, then do some operations. What are those operations? You check what is the value of tower at index L, which is index 0. So tower's height is 0, and L max still at this case, L max at this case is also 0, and R max is also 0. So I ask, is the height of tower, is my height of tower greater than my L max or equal to? Yes, it is. So L max will be updated with that value. Otherwise, we will store some answer. Here it is not going to be the case. So do L plus plus. Now my left is at this index. Okay. Check for the same case. What is ARR of L? ARR of L now is what? It is 1. ARR, this is ARR of L I'm writing. Okay, ARR of L right now is 1, and ARR of right is still at this position, which is also 1. So in the case they are equal, again we are going into this loop in this condition and check. Now we are checking ARR of left is 1. What was your L max? L max was 0. So ARR of L is greater than your L max. So L max will be updated with that current index value, that will be 1, and then L plus plus. Now your L is at this position. At this position. Okay. So what do you check? Now you check again, same thing. ARR of L is what? ARR of L is at 0, and ARR of R is 1 again. Again, it is less than ARR of R. So when I'm at this position, again, I check what is the L max. L max is greater than your ARR of L in this case, right? It is greater than that. That means I can store some water. Why? Because see, current value, when current is less than your L max, this basically means that whichever position you are in the array, that means you can store some water because your L is greater than your current height of tower. Okay, I hope you're understanding this thing. What I want to explain is, let's say whichever I'm at this position, and if this value is less than my L max, if this is less than my L max, which means I have some L max which is greater than that, so I can store some water. Now you will say, how do you know you can store some water? You have not checked for right. So at this part I will come, let me just complete the explanation, then you will understand that why am I not caring about this part as of now. So I'm just checking and comparing it, that if it goes in the else condition, that means your L max is greater than your current value. So here L max was 1, current value was 0. So 1 is greater than 0, that means I can store some water. And what is the amount of water that can be stored? That would be L max, because that is greater than my current height, minus my own height, which will be ARR of L, right? That is the amount of water I can store, that I have written here, and add it to the answer. So answer was initially 0. Now it has become 1 because 1 water I have taken from this position, and move your L to the next index. Now what is ARR of L? ARR of L is 2 right now. ARR of R is still 1. Now you will go to the else condition because your left tower is greater than your right tower. So that is handled by right else condition. Now you are doing some operations on right index. What are those operations? So your right is at this position. Okay. You will check ARR of R. ARR of R is 1. Okay. And what was R max? R max was 0. So if R max is less than your current value, which means that let's say you are at some position and your R max is less than you. Let's say you are at some height, your tower has got some height, and your R max is not greater than you, means let's say it was 0. Let's say. So will you be able to store some water, considering that? Don't worry about the right part. You don't have to worry about the right part, left part when you are dealing with the right index, and vice versa. When you are dealing with the left index, don't worry about the right part. Just think about right. So when you are at right pointer and your right max is less than your own value, that means you cannot store any water. So just simply update R max with your own value, which will be ARR of R, and move to the left value. Now come to this direction. That's what we are doing in this case. If ARR of R, if ARR of R is greater than or equal to your R max, right? Then just update the value of R max to 1 and move your right pointer to the next left index. Now you are at this position. Again, do the upper comparison, which is comparison between left tower and right tower. So both are equal. So in that case, I will go to the first condition, which is this condition. Inside this condition, I'm again now I'm checking for left index value, and the tower at left is of height what 2, and the Lmax is what 1. So Lmax is less, so I'll simply update the value of Lmax and move to the right position. Now I'm at this index, my right is at this index, so my left is still smaller than right. So in that case, I will move to the first condition and go inside. I will check what is ARR of L. ARR of L is 1, right? And what is your Lmax? That is 2. Lmax is greater than 2. That means some water can be stored, right? So what is the amount of water? That will be the Lmax minus your own height. That will be 1. So add that to your answer. It will become 1 and move L to the next index, right? Understood this thing? Now at this position. Again, we check left with right. Left is smaller. So first case, now we are again checking for the left index. What is your Lmax? Lmax is obviously greater than your own height. So what is the amount of water you can store? That will be your Lmax minus your own height. That is 2, right? Move your L to the next index. At this index, what is Lmax? 2. What is your own height? 1. Lmax is still greater than you. So you will store some water. That will be Lmax minus your own height. That is 2 minus 1 equal to 1. Move to the next pointer. Move to the next index. L. L is now 3. This is your 3, right? Now you check when you, we are always checking this condition, we are always checking this condition, then we are going in if and else. In this case, when we are at this position, your R is still at 10th index, right? R is at 10th index. What is the value at 10th index? That is 2. What is the value at 7th index? That is 3. Sorry, this will be 2 only. Now you are at value which is height 3. Your Lmax is 2 till now. So left is greater than your right index. So you are going to do some operations on your right indexed values. Okay. So what you're going to check, what is your ARR of R? That is 2. What is your R max? That is 1. So simply update your R max with 2 and move your right pointer to the left. Now you check, make comparisons of left with right. Left is 3, right is what? 1. Again, right is smaller. So you will do some the smaller one on this. Whenever you find the smaller one, you do the operation on that pointer, right? So R is smaller, so you do the operations on this pointer, and the comparisons are that its own value is 1 and R max is 2. That means if R max, I am getting 2 from here, right? If R max is greater than my own value, means I can store some water. Just understand it this way. If I can store some water, that would be equal to the R max minus my own height. That will be 2 minus my own height, 1. Okay. And then I will move one pointer, one left side, which is at this index. Now compare L with R. R is smaller, so my operations will be on R. Okay, and what are those? Now check R. What is ARR of R? 2. What is your R max? Still 2. So it will hardly make any difference. No water will be stored. If even if you calculate, it will be 0 and your R max will stay 2 only. Now R will be at this index where your L was present at 7th index. So when you compare both of them, when it is equal, we are going in on the first condition, that is this. Compare L with R. Can you store some water when you are at the same index only? You can't. So what is the answer? 1, 2, 3, 4, 5, 6. That's how you are iterating, and you are using 2 pointers here. Using 2 pointers, you are making your calculations of same thing that we discussed in this first approach. In this first approach, the thing was, it was not very, it was intuitive, and based on an intuition we use some extra space to calculate Lmax and Rmax. Now in this case, to get Lmax and Rmax, I don't want to use any space. So how can we solve it in same time complexity on and without using any space? So for that, some manipulations are being done here. Now how do these manipulations hold true? Now you are saying, how are we ensuring that whenever I get a smaller value height, whenever I get a smaller tower, I start operating on that index. I have 2 pointers, left and R, right? So I have left, look here, I have 2 pointers, left and R. Whenever I get a smaller one, I start operating on that index. So if L is less than or equal to R, then I do the operations on left index. Otherwise, I do the operations on right index, which can be mapped from this. If left was smaller than right tower, basically, not, don't confuse with the literal indexes. I mean the height of left index, height of right index, right? So if that is smaller, I'm operating over left index and doing these operations, otherwise right index and doing these operations. Now you will ask me that, let's say, when I was at this position, maybe, or maybe at this position, whatever position I am at, how am I ensuring at a time I'm only operating over one index? If here it is left is smaller than right, then I'm making checks for left index values only. That is because, see, I am already ensuring while I was doing the iterations, my left was at this position, my right was at this position, let's say. My left is at this position, my right is at, let me be here. Let me be here, and my right be here. So left is what? What is the height of this tower? Height of this tower is 0. Height of this tower is 1. Which is smaller? Obviously, this is smaller. So one thing is clear. Imagine it in this way, that if no other towers were present and only this 0 tower and this 1 high tower were present, so it would have looked something like this. So obviously, if I can find if there is some L max to store water, obviously at right I'm going to get one tower to store some water at its own height, right? Because when I'm doing this check, I'm ensuring that either from the right there is some tower to hold water, or if I'm going to the else condition, I'm going to the else condition when my ARR of right means right tower's height is less than your left tower's height. That means from left end, I can be sure, from left end side, I can be sure that there is some tower to hold the water. So what operations I need to make? I need to only check for if I can get some R max to store the water. Understood? So this is the logical understanding. Logically, this is how we are handling with ARR of, with this operation. If ARR of L is less than or equal to ARR of R, this if condition itself is handling a lot of things, that for whichever index I am, let's say when I am at this index, it checked that at right I have some tower which can store water if I have to. So I don't have to worry about right side. Now just be worried about left. So for that I make these comparisons. Then I check, for me, do I have some L max? It says yes, I have some L max which is greater than me. So I say, if that is the case, if L max is greater than me, which is the else condition, so I can store some water which is L max because that is greater minus my own height. And if let's say that was not the case, that means I cannot store any water, just update the L max and go ahead. So these are your two if else condition, whatever the case is. Once you are done with the evaluation, just move your left pointer to the next index. And similarly, for the right hand side, you can visualize it and understand in the same way. And since we are moving in directions like this, and that's the maximum operation of on of time complexity. So maximum on of time complexity and no space we are taking. So I hope you have understood this problem. This is the intuitive, this is the logical explanation of how intuitive approach was made in the optimal way. That is this approach, and I hope you have understood, so that now we can move to the coding part. Okay, so let's move to the code now. Yeah. So exactly what I just explained, I'm going to write. See, code is very easy. Code is not going to be difficult. Only the intuition and the logical explanation behind the intuition is what that matters. Okay. So int left index is at 0. Int right index is at your last index. Okay. And then you are using Lmax, which is 0, int Rmax, which is 0. Let's say int answer is 0. That is the amount of water that you are storing. So while your left is less than or equal to right, then what are you doing? You are checking if your ARR of L, it is less than or equal to ARR of R. Okay, then you are doing, then again you are making two checks on the left index value. If ARR of L is less than your L max, okay, which means L max is greater, so you can store some water. And if you can store some water, you can do answer plus equal to L max minus your own value ARR of L, right? If not, you will update your L max with ARR of I, right? That is the intuition, ARR of L. And if, and then this should be else, and then you are doing L plus plus. Similar thing you are doing when your ARR of R is smaller than your ARR of L. In that case, if ARR of R is less than or equal to R max, that means you can store some water. So ANS plus equal to R max minus your own height ARR of R should go to the answer. Otherwise, update your R max with ARR of R and then move to the next left index, that is move to the index one less than your current index, that will be R minus minus, and finally what you want to return is your answer. Let's check. I think one issue we will get, what int answer, you have to return a long type of answer, means the amount of water should be of long type. Rest in int would work. And let's check. That is all. I hope you have understood this problem. See, the code hardly takes seconds. It's all about the intuition, optimization, and the logical explanation behind that. I just hope that you have all understood this problem. If you have any doubt, you can ask. Otherwise, that's all for this. So that is all for today, everyone. Let me check my whiteboard. Yeah, this is what I explained. You can have a look on it. So this is what we discussed today. And that is all. So let's wrap it up, everyone. See you all in tomorrow's lecture. Thank you, everyone. Bye.